Inflammation contributes the disease process. Kirst, Edel, 1989. Also, elevated plasma concentrations of cytokines in aged humans have been reported. Tyarani, et al., 1989. In this study, elevated level of IL-6, TNF-A, CRP and IL-1A has been found in aged mice, which itself suggests a direct role of inflammatory response in aging progression. The elevated inflammatory response may be due to impaired peripheral immune responses which may activate innate immunity as well as hormonal changes. This marked increase in pro-inflammatory cytokines may result in INOS expression which induces NO synthesis. Mandern Brown, 2004. Curcuma is an established anti-inflammatory agent, and in this study curcuminoids show promising activity by reducing the elevated cytokines levels in aged mice. Simultaneously, bacchicides are also found to show potent action in decreasing the elevated inflammatory response in aged mice, proving its multifactorial effect in amelioration the aging deficits. To sum up, all the three plants-derived drugs show protective effects on aging and age-related pathologies by ameliorating various pathways such as neurochemical modulations, mitochondrial impairment, oxidative stress and neuroinflammation. These data provide pharmacological basis for the therapeutic efficacy of these plants in modulating age-related neurodegeneration and further suggests that the same is more useful when it is implemented early in the course of neurodegenerative disorders. Conclusion. The aging process leads to dramatic alterations in the physiology of all organisms, including reduced cellular function, compromised resistance to stress and pathological agents, and increased likelihood of developing age-related diseases process. These advances indicate that an intimate link between the aged state and the manifestation of several neurodegenerative diseases exists. However, the enigma of how old age contributes to the development of these pathologies remains largely unsolved and needs further investigation. However, the present series of study discusses some of the pathways that altered in aging and also provides the insight about the usage of natural products for the amelioration of the age-associated pathologies. These findings strongly suggests that indigenous medicinal plants possess significant potential to show benefits in age-associated deficits and may serve as one of the therapeutic and supportive measures among the aged for the prevention and management of age-related neurodegenerative disorders. References. 1. Agarwal, S., Sohal, R.S., 1994. Aging and Proteolysis of Oxidized Proteins. Arch Biochem. Biophys. 309, 24-28. 2. Agrawal A., Dubey G.P., Gupta B.S., Udupa K.N., 1992. Role of an Ayurvedic drug Brahmi, Bacopa Monieri, in the management of senile dementia. Pharmacopsychoecologia 3, 17-52. 3. Bobak, T., Smith, R.T., Petrovic, D., 1997. Current knowledge on Alzheimer's disease. Neurologia Croatica 46, 55-72. 4. Bozajur C.M., Kratolika A., Galimi F., Narita M., Low S.W., Yaswin P., Campisi J., 2003. Reversal of Human Cellular Senescence, Roles of the P53 and P16 Pathways. Embo J. 22, 4212-4222. 5. Beckman K.B., Ames B.N., 1998. The Free Radical Theory of Aging Matures. Physio Revelation 78 verses 547-581. 6. Benzi G., Pastores O., Marzatico F., Villa R.F., Dagani F., Kurdi D., 1992. The mitochondrial electron transfer alteration as a factor involved in the brain aging. Neurobiol Aging 13, 361-368. 7. Bhattacharya, S.K., Bhattacharya, A., Kumar, A., Ghoshal, S., 2000. Antioxidant activity of Bacopa monnieri in rat frontal cortex, striatum and hippocampus. Phytother. Res. 14174 to 179, 8. Bhattacharya, S.K., Ghoshal, S., 1998. Anxiolytic activity of a standardized extract of Bacopa monnieri, an experimental study. Phytomedicine 5, 77 to 82. 9. Bone K., 1996. Clinical applications of Ayurvedic and Chinese herbs, monographs for the Western herbal practitioner. Warwick, Queensland, Phytotherapy Press. 10. Brahma, S.K., Debnath, P.K., 2003. Therapeutic importance of Rasayana drugs with special reference to their multidimensional actions. 11. Buccafusco, J.J., Terry, A.V., 2000. Multiple central nervous system targets for eliciting beneficial effects on memory and cognition. Journal of Pharmacology and Experimental Therapeutics 295, 438 to 446. 12. Bymaster F.P., Heath I., Hendricks J.C., Shannon He, 1993. Cooperative behavioral and neurochemical activities of cholinergic antagonists in rats. J. Pharmacol exp. There 267:16-24. 13. Carrard, G., Bolto, A.L., Petropolis, I., Frigate, B., 2002. Impairment of proteasome structure and function in aging. Int J., Biochem. Cell Bio. 34, 1461-1474. 14. Chakravarti A.K., Garai S., Masuda K., et al., 2003. Bacopicides 3V, 3 new triterpenoid glycosides from Bacopa monnieri. Chem Farm Bull, Tokyo, 51:215-217. 15. Chakravarti A.K., Sarkar T., Masuda K., et al. 2001. Bacopicide 1 and 2, 2 pseudojujubagenin glycosides from Bacopa monnieri. Phytochemistry, 58:553-556. 16. Charles Ramasamy. September 2006. Emerging role of polyphenolic compounds in the treatment of neurodegenerative diseases, a review of their intracellular targets. European Journal of Pharmacology. Volume 545, Issue 1, pages 51-64. 17. Chung Hy, Sung B., Young K.J., Zo Y., UBP, 2006. The Molecular Inflammatory Process in Aging. Antioxidant Redox Signal 8, 572-581. 18. Ding, Q, Keller, J.N., 2001. Proteasomes and proteasome inhibition in the central nervous system. Free Radique. Biol, Med. 31, 574-584. 19. Faruqi, MYH, Day, WW, and DM Zamorano, 1987. Glutathione and lipid peroxidation in the aging rat, Comp Biochem Physial 88b, 177, 180. 20. Gallagher M., Nagahara A.H., Burwell R.D., 1995. Cognition and hippocampal systems in aging, animal models. In McGough J.L., Weinberger N., Lynch G., EDS Brain and Memory, Modulation and Mediation of Neuroplasticity. Oxford University Press, New York, 103-126. 21. George Francis, Zohar Karam, Harinder P. S. Macker and Klaus Becker, 2002, The Biological Action of Saponins in Animal Systems, a Review. British Journal of Nutrition, 88, 587-605. 22. Gunekar, B.G., 1981. Sutrasthana. In Sushrut Samhita. Motilal Banarsidas, Varanasi, page 3. 23. Gibson G.E., Peterson C., and Sansone J., 1981. Neurotransmitter and carbohydrate metabolism during aging and mild hypoxia. Neurobiol Aging 2, 165 to 124, Harmon, D.J., 1999. Anti-Aging Med 2:199. 25, Hincliffe P., Sazonov L.A., 2005. Organization of Iron-Sulfur Clusters in Respiratory Complex I, Science 309, 771 to 774. 26, Ho C.C., Lin S.J., Cheng J.T., Su F.L., 2002. Bacopicide 3, Bacopasaponin G, and bacopicides A, B, and C from Bacopa monnieri. J. Nat Prod, 65:1759-1763. 27, Jiang, C.H., Chen, J.Z., Schultz, P.G., Hu, Y., 2001. The Effects of Aging on Gene Expression in the Hypothalamus and Cortex of Mice. Proc. Nadel, Academic, Sci., USA 98, 1930-1934. 28, Keller, J.N., Haney, K.B., Marksberry, W.R. 2000a, Impaired Proteasome Function in Alzheimer's Disease. J. Neurochem. 75, 436 to 439. 29, Kirst, A., A., Kaplan, E. and Schoeman, D., 1989. Growth Dev, Aging 53, 117 to 12. 30, Kopelman M.D., 1986. The Cholinergic Neurotransmitter System in Human Memory and Dementia, a Review. QJEXP Psychol 38, 535 to 573. 31, Capito, R. R., 2000. Agrosomes, Inclusion Bodies and Protein Aggregation. Trends Cell Bio, 10, 524 to 530. 32, Li, J. Chang, C.K., Liu, I.M., Chi, T.C., Yu, H.J., Cheng, J.T., 2001. Changes in endogenous monoamines in aged rats. Clinical and Experimental Pharmacology in Physiology 28, 285 to 289. 33, Lenas G. Bovina C., Castelluccio C., Fato R., Formigini G., Genova M.L., Marchetti M., Pitch M., Pallotti F., Parenti C.G., Biagini G., 1997. Mitochondrial complex I defects in aging. Mole Cell Biochem 174:329-333. 34, Mahato S.B., Garai S., Chakravarti A.K., 2000. Bacopasaponins E and F, 2 jujubogenin bisdesmosides from Bacopa monnieri. Phytochemistry, 53:711-714. 35, Mander, P., and G. C. Brown, 2004. Nitric oxide, hypoxia and brain inflammation Biochemical Society Transactions, Volume 32, Part 6. 36. Mazer, C., Muniersi, J., Tahini, K., 1997. Serotonin depletion during synaptogenesis.